Before we write a single line of code, let me show you something. This is an interactive visualizer and it is going to show you exactly how stack algorithm works. Before we even touch the code, let me walk you through what you are looking at. On the left hand side, you see our flat list of headings. Chapter 1, then 1.1, then 1.2, then chapter 2 and so on. On the right side, you will see a tree that we are building. Right now it is empty. In the middle, you see the stack. The stack is the heart of this algorithm. It keeps track of where we are in the hierarchy. Let me click next step and show you what happens. Look at the stack. It starts with something called a virtual root at level 0. Now, this is not a real heading. It does not exist in our document. It is just a helper. So our algorithm has something to start with. Think of it like the ground floor of a building. You need it even if nobody stays there. The tree is still empty. No headings processed yet. Click next step. Now we process the first heading, chapter 1 at level 1. Look at the status bar. It says stack top level is 0, current level is 1. Pushing deeper, even current level is greater than the parent level. Pushing deeper because the current level is greater than the parent level. Now look at the stack. We push chapter 1 onto the stack. The stack now has virtual root. The stack now has virtual root at the bottom and chapter 1 on top. And look at the tree on the right. Chapter 1 appears at top level node. No children yet. Now let me explain the while loop that made this happen. The code checks while stack -1 level is greater than equal to current level. Stack -1 this means the top of the stack. Right now, the top is a virtual root at level 0. So the question is 0 greater than or equal to 1? No. So we do not pop. We simply add chapter 1 as a child of whatever is on top, which is virtual root. And then we push chapter 1 onto the stack. This is easy case. Going deeper, click next step. Now we process 1.1 installation at level 2. Look at the stack before processing. Top of stack is chapter 1 at level 1. Current level is 2. The while loops check is the top level, that is 1, greater than or equal to current level, that is 2. No, 1 is not greater than equal to 2, so we do not pop. We add 1.1 installation as child of whatever is on top, which is chapter 1. Look at the tree on the right. See how 1.1 installation is indented under chapter 1. That indentation means it is a child. Now we push 1.1 installation onto the stack. The stack now has 3 items: virtual root, chapter 1 and 1.1 installation on top. Again, we go deeper. Click next step. Now, this is where it gets interesting. We process 1.2 configuration at level 2. Look at the stack before processing. Top of the stack is 1.1 installation at level 2. Current level is also 2. The while loop checks is top level 2 greater than or equal to current level 2. Yes, 2 is equal to 2. So we pop. Watch the stack. We removed 1.1 installation. Now the top of the stack is chapter 1 at level 1. The while loop checks again. Is 1 greater than or equal to 2? No, so we stop popping. Now we add 1.2 configuration as child of whatever is on top, which is chapter 1. Look at the tree. Both 1.1 installation and 1.2 configuration are children of chapter 1. They are siblings. Now we push 1.2 configuration on the stack. The stack now has virtual root, chapter 1 and 1.2 configuration on top. Notice something important. 1.1 installation is gone from the stack, and that is exactly correct because we are no longer inside 1.1. we moved to its sibling, that is 1.2. Now we process chapter 2, which is at level 1. Look at the stack before processing. Top of the stack is 1.2 configuration at level 2. Current level is 1. The while loop checks, is top level 2 greater than or equal to current level, that is 1? Yes, 2 is greater than 1, so we pop. We remove 1.2 configuration. Now top of the stack is chapter 1 at level 1. The while loop checks again. Is 1 greater than or equal to 1? Yes, 1 is equal to 1, so we pop again. And we remove chapter 1. Now top of the stack is virtual root at level 0. The while loop checks again. Is 0 greater than equal to 1? Is 0 greater than or equal to 1? No, so we stop popping. Now we add chapter 2 as child of virtual root. Look at the tree. Chapter 2 appears as a new top level node. It is a sibling of chapter 1. Now we push chapter 2 onto the stack. The stack now has virtual root and chapter 2 on top. This is going back up the hierarchy. From level 2 all the way back to level 1, the stack kept popping until we found the right parent for chapter 2. Click next step. The remaining headings follow the exact same pattern. 2.1 basic commands at level 2 becomes child of chapter 2. 2.2 advanced features at level 2 also become child of chapter 2. Notice the stack pops 2.1 before adding 2.2. Then 2.2.1 nested option A at level 3 becomes child of 2.2, and 2.2.2 nested option B at level 3 also becomes a child of 2.2. Watch the stack pop 2.2.1 before adding 2.2.2. And now all the headings are processed. Look at the final tree on the right, every heading in exactly the right place. Now look at the bottom right bottom. It shows you the entire algorithm logic. Let me explain what is this doing. Stack -1 is top of the stack. We check its level against the current heading's level. If the top of the stack has a level that is greater than or equal to the current heading's level, that means we are finished with that node. We need to go back up. So we pop it off the stack. We keep popping until the top of the stack has lower level. That remaining node is the parent. Then we add current level as child of that parent. And we push the current node onto the stack, so further headings can become its children. That is the entire algorithm. It is simple, it is elegant, and it works perfectly. So here's what you just saw. 3 situations and 3 responses. Going deeper, level increases. Pop onto stack, no popping. Push onto stack, no popping. Going same level, that is siblings. Pop the previous sibling, then push the new one. Going back up, level decreases. Pop until you find the parent and then push. The stack always know where you are in the hierarchy. When you go deeper, you push. When you go back up, you pop. And this is not some exotic algorithm we invented for this course. It is the same algorithm used in file system, HTML parsers, and compilers. Now that you understand how it works, let me show you the Python code for it that implements this same exact logic. See you in the next video.